One. Hi, welcome back. We're here with Richard Pressler, and we're talking about Module 1, Network Fundamentals. I'm assuming that's going to kind of cover the basics that we need to have in place as we move through the rest of the course. So can you describe, I know that one of the things is structured cabling is a big component. Can you really describe what that looks like in a typical school setting, and what aspects of cables are unique to K12 networks?
Sure, absolutely. I'd be happy to. So when we say structured cabling, we're really talking about the cables that run inside the walls between the computers and the network closets, and then also the cables that run between buildings, for example. So in a typical K12 environment, we have a good amount of fiber optic cable, for example, that runs between buildings. So there's a lot of fiber optic cable usage, and we're using fiber optics primarily because of the distance between buildings. Or in some cases, the distance between floors in a school. And then when it comes to the actual connections to endpoints, to computers or to access points or to smart TVs, it's typically going to be copper cabling. Nowadays, it would be category 6 copper cabling. And if you don't know what that means, you will by the time you get through network fundamentals. But essentially, this is cable that's capable of carrying data at a high speed as well as power. It's important to talk about power over Ethernet because most schools require it now for access points or cameras or other things that are attached to the Ethernet network. The main thing that's unique about the K12 environment is that there is a large number of access points, for example. There's a lot of cabling devoted to them. There's also cabling that's necessary for things like smart TVs and other educational platforms, smart projectors, things like that need to be taken into consideration when laying out a structured plant, which is the phrase we use in the industry for describing how all of the structured cabling comes together inside of a building.
So Richard, I understand there's a difference between, I understand conceptually the difference between copper and fiber optic, but what are some examples of it? Do schools tend to use more of one or the other, or what's unique about that distinction in K-12 settings?
Sure. So as you already understand, Dan, fiber optic indicates that all the data communication is happening via light, whereas copper cabling, the data communication is happening via electrical signal. Now, there are distance limitations, and that's the primary consideration, and it's also the primary reason why you would use fiber optics in the first place, because it is more expensive. It's more expensive to purchase. It's more expensive to install. It requires some specialized skills in order to terminate fiber optic cables. So most school districts are going to lean towards copper cabling just from a cost perspective. I'll give you a couple of exceptions. For example, fiber optic cabling might be run to desktops that are responsible for rendering work or responsible for film editing, video editing. That industry, the video editing industry, tends to use fiber optic to their desktops mainly because of the performance. And they require the absolute best performance that they can get. And so it's not uncommon to see it in that situation. But outside of a school that was trying to specialize in, say, video editing, primarily we're seeing copper cabling.
So one of the assignments addresses or looks at equipment installation. So can you talk a little bit about some of the more important things to consider when you're installing equipment, and then, share a couple of stories or some things that you know about that where people maybe have made some mistakes when they're trying to cut corners, or as we talked about earlier, if we're addressing budgetary constraints.
Sure. Well, we have budgetary constraints in K-12 schools. I've never heard of such. No, I understand. So when it comes to installing equipment, I've seen the worst of the worst, you could say. I've seen equipment rooms where the room that the computer network equipment is the same room that all the electrical subpanels are in, and it's very dusty, very dirty. It might even have an exterior facing door. So every time the janitor comes along and he's cleaning the patio or the sidewalk, it blows all that dirt and dust into the room and gets all over the equipment. And some of this equipment is quite expensive. So it does break my heart a little bit to see a $5,000 or $6,000 piece of equipment in a room where basically its life is going to be shortened because of the amount of dust and dirt in the room. There's also other environmental concerns. I've seen rooms that run way too hot in the summer, or rooms that have very poor ventilation, and therefore the air isn't really moving in the room, and that can essentially cook the chips inside of the equipment. So it's important to take these things into consideration. Basically, you want to look at the room location that the equipment's going to be in. You want to look at the environmental considerations for the room, and those are some of the things we're going to be discussing, is what are the environmental constraints of the equipment. And like you mentioned, a lot of it comes down to budget. Now, that's not to say that the equipment's not pretty resilient. In fact, I had one school district where they had a switch that was failing on a daily basis, and they asked us to investigate it, and we found that there was a potted plant sitting on top of the switch. And sure enough, every day when the office administrator would water the potted plant, the water would seep into the switch, and the switch would internally short and die. And then it would dry out after about an hour or so and just power itself back on. Amazingly resilient, but that is definitely not recommended. That's not something you really want to see in your school district. And obviously they were annoyed with the fact that they were down for 1 hour out of every day. But you can see the importance of putting equipment in a place where it's going to keep it, basically maximize its lifespan.
So speaking of equipment, so can you describe the basic types of, I guess there's switches and routers and stuff like that. And like, for instance, do people sometimes have to use the wrong kind of equipment, or you must have to sort of make do with stuff that's already there? Does that happen more in schools? Do you have any more great examples like that last one?
Pouring water on equipment? Most schools don't do that, thankfully.
They don't make waterproof equipment. Do they make waterproof equipment?
Yes, it's generally encapsulated into something else to make it waterproof. But if you imagine what goes on for like deep sea missions, they have to make waterproof equipment. There's a lot of equipment that's out there on the ocean with the Navy and other entities. So yeah, they make waterproof equipment. I don't see any of it in schools, though. I'm sorry to say. Haven't visited an underwater campus quite yet. Maybe in the future. But the types of equipment, as you mentioned, there's switches, and that connects computers and access points and other pieces of equipment to the network. And then there's routers, so that equipment can go between different networks. In fact, by the end of the module, you might be starting to conceptualize an image in your head of the internet as really just a whole lot of routers, because that's really what it is. It's pieces of equipment communicating with each other that are all basically forming networks, and they have the ability to understand how to send packets back and forth between various networks. But in a K-12 environment, we also typically are going to have firewalls, and those will protect the school district from the internet. So attacks coming in over the internet will be blocked generally by the firewalls. There will be access points in a typical school district. Some school district will even use wireless bridges. They'll use wireless equipment in order to connect different buildings together. And so that's not uncommon within a school district. And yes, some school districts that we come into, they're trying to maximize the lifespan of the equipment. So they'll have equipment that's easily 10 or 15 years old. And so it doesn't run at the speed that current equipment does. And they're still trying to make it work. The areas where you really suffer is when you need the bandwidth and the piece of equipment just doesn't offer it because of its age, or it's just in the wrong place. There's also times where a network has the right equipment, but it's simply not connected correctly, and it can create problems there as well. And we're really going to get into that in Module 3, actually, when we talk about network resiliency.
Great. And so one of the last things in this module is understanding the basics of the OSI model. Can you tell us what OSI stands for, and why is it important for someone working in a K-12 environment, working with networks and stuff, to really understand the OSI model, and maybe a couple of brief descriptions of what this model is and what each component of the model is?
Sure, I'd be happy to. So OSI stands for Open Systems Interconnection. And the other assignments in this module are going to focus on things you can see and touch. So cables, equipment, rooms that the equipment goes into. All of that are things that you can see with your own eyes. But the OSI, when we say model, what we really mean is that it's an abstraction. It's a description of how computers can communicate with each other. And as such, you're going to look at this model, and as we consider it together, you're going to see that it's broken up into layers. And the layers follow mostly the logical way that you would think that two computers would talk to each other. For example, they have to have some medium to communicate. There has to be some way of transmitting electrical signals or light or something between the two computers. And so that layer is called layer 1, or the physical layer in the OSI model. And then there has to be a language agreement between the computers. Just like I'm speaking English right now and you understand what I'm saying because we speak the same language, so two computers have to fundamentally speak the same language. And layer 2 really talks about that with data link communications, very low level communications between computers. Layer 3 focuses on networks. How is a logical network built? And how do you route between logical networks? All of that kind of is exposed within the layer 3 of the OSI model. And layer 4 has to do with the transmission of data. Confirmation that data that was sent by one computer is received by the other computer. And that's not an uncommon concept. We use it all the time. So for example, here I am talking on camera, but if the camera feed was cut off, I may have no way of knowing until I say something like, hey, Dan, can you hear me?
I can hear you.
See, I received confirmation from him. And layer 4 of the OSI model is all about that type of confirmation. Did one computer send data, and did the other computer confirm receiving it? And then layers 5 through 7, we're actually not going to spend a tremendous amount of time on them because they're really focused on the applications. So applications running on a computer definitely need to talk to each other, but it's not common for a network engineer to dive too deeply into those layers. So we're primarily going to focus on layers 1 through 4.